Okay, good morning. I have published a quiz assignment on Google Classroom for Math 5 and the due date is next Sunday. So if you get time, there are 5 questions, easy ones, you can just do them. We can also cooperate together and answer those questions. So I just want to see how it is going. So those are not going to affect your grades in the course, okay? But I just want to see that if many people answer wrongly, it means that there are some misunderstandings. So that's only for myself, so that I can see what is the weakness or something else like that. Okay, so try to work on those problems in good time. There are 5 questions, and then finally you need to answer one of those, and it will be automatically be corrected. You will realize which questions you have answered wrongly. Okay. So let us continue a little bit of lesson today, and then I will probably give you a little bit of time to practice on yourself, and if you have any questions, please let me know. So we talked about sets, we talked about when the sets are equal, we talked about the notion of being a subset, and now all of this would be completely useless if we cannot somehow work with the sets, combining sets together and things like that. It's like that you have the mere notion of a number, 2, 3, 5, etc., and you don't know how to add them, multiply them, subtract them. So you need to do some operations with those numbers, yes? The same is true here. We just learned what the notion of a set is. Somehow we are familiar with it now. So the question is that how can I combine these two? How can I do algebra with sets? That's the whole point, yes? In this case, we want to define something analog to the negative. Okay, it's not related at all, but the motivation might be there. If I have a number, I have the negative of that number, 2 minus 2, 3 minus 3, etc. Okay, now more or less, first of all, I give you a set and I want to define the complement of the set. Okay, so that's the first lesson today, and it's a very, very easy, simple concept. So definition. The complement so this is the word that we want to define. The complement of a set A is denoted by A, on top of that we put a C. Read it A complement. The complement of a set A is denoted by this symbol. Of course, in some other books I have seen they use A prime, but that is not universally adopted, so let us just use this symbol. So it's denoted by A complement, and it is defined as follows. Of course, when I want to define something, I have to define it for you. But this word brings something in mind. So how do you think? What's the meaning of a complement? Of course, I don't expect you to know because I'm just defining it. But what is, yes?
If you add them together, then it becomes 0.
No, that's not meaningful. Yes, what might be my analogy was misguiding. Yes, because adding 2 sets we haven't defined. What do we mean by adding 2 sets? Yes, but the complement. So forget about that example. So it might be that is really, really misguiding. Sorry for that. But A complement means not in A. The complement. What makes A complete? Yes, with respect to the universal set. So when you have the universal set, whenever you want to work with the set, you need to choose some elements from the set. I don't know, this is complaining that the video might lag behind. I don't know why. Anyway, so let me just define it for you. So A complement is defined to be the set of all x's. What are the properties? Of course, I emphasize here that X should belong to U and X should not belong to A. So that's the complement of the set A. So when I say complement, I am asking you find all elements that are of course in the universal set. All the elements should come from the universal set by the definition of the universal set. But I have to be careful not choosing even one single element from A itself. So if I want to give you an idea what is going on, if this is the universal set, if this is the Venn diagram to represent this somehow, this is the universal set, and then you have a set here. This is your set A. Whatever is outside this is called the complement, yes? So let me just try to visualize it a little bit. So if I ask you represent a complement somehow in this picture, yes, I hope that you have a rough idea what is that. This is just a complement. So whatever is in the universal set, but it is not in the set itself, is called the complement of that set, and it is denoted by this symbol. So I cannot just ask you what is the complement of a set. I have to already tell you what is the universal set, because if I don't give you the universal set, you will not be able to give me the complement of sets. Yes? Sometimes we have something by default. For example, if you are talking about numbers, usually the set of real numbers is to be assumed the universal set. So when I talk about the complement, I am comparing the complements of sets of numbers with respect to the real number. But this is not a have to. If I want to be really clear, I have to tell you what is the universal set, then I give you a set and I ask you to find its complement. Yes? Is that clear? So what I was thinking that you are telling that if I put these together, add them somehow, we will see what is the notion of adding in sets. It's called the union. If I union them, if I combine them, it becomes the universal set, not the zero. Because zero is analog of the empty set somehow. So if I combine them, it becomes the universal set. So that's the definition of the complete complement of a set. So let me just give you a very simple example. So so here I am telling you what is U. So let U be the set of all numbers such that they are natural numbers. Again, for natural numbers, I'm assuming they start from 1, and let this and A be equal to 1. No, 1 is not acceptable, yes, because 1 is excluded from the set of the universe, from the universal set. So let me start with 3, 5, 7, 8, and 9. Determine a complement. Yes. So what is a complement? I need to know the universal set. Of course, it is given. If I want to write it as a list of elements, so I can write the universal set is equal. So by the way, I haven't mentioned that this is the universal set. Whenever in this context, I'm always using this capital U for the universal set. So X is 2, U is 2, 3, 4, 5, 6, 7, 8, 9, yes? Here the universal set is not that big, it's actually very small. It contains 1, 2, 3, 4, 5, 6, 7, 8 elements. And now I want to find a complement. So what does this mean? This implies that a complement is equal to all these elements that you see in the universal set, but they are not in the set itself. Yes? So for example, 2 is in the universal set. It is not in the set itself, so I write it here. And then 3 is here and there, so I don't write it. 4 is here but not there, so I write it. 5 is here and there. 6 is here, not there. Yes, is there something else? No. 7, so this is close. So that is the universal set. Yes, is that understandable? So very, very simple concept. For example, what do you think this will happen? Example, if U is equal to R, then, for example, if I ask you what is the Q complement, Q is the set of rational numbers, then what is Q complement? Yes? The set of irrational numbers, exactly. Because you remember what was the definition of an irrational number? An irrational number is a number which is not rational. That's the definition. And whatever you put here, you are putting all those numbers that are real numbers. They are numbers, but they are not in Q. They are not rational. So it becomes irrational. And then, if you remember, this is the symbol we use for the set of irrational numbers. Yes? For example, if the universal set is the set of natural numbers, what is the complement to the set of all even numbers? Is the set consisting of all odd numbers. Yeah, so this is very simple and clear. Okay, so let us see some properties. So let me write this as a theorem. Let A be a set. There are some properties that you can immediately realize what they are, what is the answer to them actually. So I would write it for you and then wait for you. So if I have a complement and I complement it again, so what do you expect to get back? Yes? A itself, yes? So this is U. When I make a complement, I mean whatever is in this rectangle but not here. So it means this blue part. And if I ask you what is the complement of the blue part, automatically it becomes this white part. Yes? So a complement is equal to itself. Okay, so what happens for 2? What is the complement of the empty set? What is that? Yeah, it's intuitively very clear. The universal set. The complement of the empty set is the whole package U. Yes? Is that clear for everyone? Because what you write in the complement set, you are asking all the elements. So let me write. If I want to be very pedantic and write everything, so you write X belongs to the universal set, and X does not belong to the empty set itself. But this is automatically satisfies all the time, yes, because empty set doesn't have any elements. So this is always true. So we don't need to care about this part because this is always true. So what we care is that X should belong to U. So you can write it as the set of all X's such that X belongs to U. This is another way of saying this is U itself, yes? So the complement of U is this. And then what happens if I have the complement of U? What is the complement of the universal set? This is the empty set, yes? So that's the empty set. So these are the things that are very clear, even though technically you need to write them if you want to prove them, but that's not necessary here. So this is the relations that I want you to know. There are two more relations. So let me write let A and B be sets. Okay? So let us write something in number 4. In number 4, I ask you, if I tell you two sets are equal, what can you conclude about the complements of these two sets? If two sets are equal, then what happens for their complements? Yes?
Is AC equal to B?
Yes. Yes, so the complements are also equal. So if two sets are equal, it's clear that the complements should also be equal and vice versa. Yes, that's very clear and trivial. But something that might be a little bit more interesting, I just want to ask you about this. I think Venn diagram will motivate you to answer this correctly. Okay, so if I have a set A, which I know is a subset of another set B, so here it means that if I have equality, I can take complements from both sides and keeping the equality again right. Correct, yes? Now my question is that, can I just conclude and write complement of A is a subset of complement of B? If the answer is yes, why? If the answer is no, can I make it right and defend yourself again for that claim? Is the question clear? Here, if I tell you if A is equal to B, you realize that you can conclude that complements are also equal. Now I am asking you, I am giving you two sets, and I am telling you that one of them is a subset of the other one, and I am asking you, how is the relation between the complements of A and the complements of B?
The complement of B is the subset of the complement of A.
Yeah, is that understandable for everyone? It would be the other way around, yes? So first of all, if you want to understand it at the level of Venn diagram, so if I have this, a universal set, and if I have this set A, which is a subset of set B, if I ask you where A complement is whatever outside this smaller circle. And if I ask you what is B complement, you would say that what B complement is whatever outside this bigger circle. So then it is clear what is outside this bigger circle is a part of what is outside of the smaller circle. Is that understandable? Yes or no? Everyone? So it means that this is very important to know that if you want to take complements from equality, from both sides of an equality, you don't have any problem. You just put this one there. But if you want to do it for a subset relation, you can do it, but you need to remember, change the order. Yes? So you need to remember to change the order. Okay, so I want to prove mathematically, of course this was clear from this intuitive picture, but I want to prove it with real mathematical proofs. But before that, let me ask you a remark. Can you also answer that? So, assume that you have a set A in the context of, I don't know, you have a universal set somewhere, and then you are picking sets from that universal set. And then my question is that, so let me write this as a remark. Of course, this is a simple thing, you already know, but let me just formalize it by writing it down. So if I tell you that I looked, an element is not in a set A, what can I conclude about this element? So you see, I have a set, I looked into the set, I saw that element called X is not in the set. Where does this X belong? Yes? To A complement. Yeah? So whenever this happens, you cannot immediately conclude that this is in the complement. So, but if this is in A, what can you conclude about X and A complement? It is not in A complement. Yes? Is that clear? So, or otherwise, if X belongs to A complement, it does not belong to A. If X does not belong to A complement, definitely it belongs to A. So these are the very simple things, but it's better to write them down formally. Okay, let us go back to a proof for number 5. So why number 5 is actually correct. So if I want to write it for, this is important. This is something that you need to learn in Math 5. So let me write proof number 5. So what is the starting sentence? Yes?
Just so you don't confuse anyone, on the second row, you forgot to...
Okay, thank you very much. Thank you. Please always correct me if I am writing something wrong. Okay, thank you. So proof number 5. What do you think I will start? So here, this is my assumption. In mathematics, it's called premise. Okay, so what you assume is a premise. So this is P, if P then Q. If I have two statements, if P then Q is a compound statement combining these two in this way, and then this is called the premise, okay? That's the conclusion. So here the premise is A, so premise means the assumption. My assumption is that I have two sets, A is a subset of B, okay? and I want to show that B complement is a subset of A complement. You really need to learn how to write the proofs a little bit in this course. So what is my starting sentence, or what would be your starting sentence? You have freedoms in choosing your words, of course, but you need to follow some structure sometimes. Yes? What would be? My goal is to show that B complement is a subset of A complement. So what should I do? No, this you need to know. I want to show a subset relation. What I have to show? I want to show a set is a subset of the other set. There is only one way to show it. How? No, it's not possible that you don't know, unless you really don't understand the subset relation. So I want to show that. I give you two bags. I want to show that. I want to ask you why this bag is a subset of the other one. What do you do? Yes?
For all X or Matematik.
Just it's very informally. So you just talk about what I look into this bag, check the elements, and check the elements in the other bag. If whatever in the first bag is also in the second bag, I am done. So why do you hesitate to say that? Because that's the meaning of being a subset, yes? Is that understandable? So when I say mathematical proof, it shouldn't be necessarily a hard thing. So you need to follow. I want to show that this guy is a set, is a subset of this set. What I have to show, I should pick any element from B complement and try to convince myself that that picked element is also an element of A complement. Yes? Yes or no? Okay, so I would say that let. Okay, what should I write? Let. Let what? No, let X be the name of that element which I have chosen from B complement. Yes? Yes or no? I want to show B complement is a subset of A complement. What I have to show that whatever is in B complement is also in A complement. But I don't know what is really in the B complement. So let me just give one of those elements a name. Let X be a typical element of B complement. I really don't know if X is there, if Y is there, if a number is there. We don't care. X is the name that I am giving to any typical element of B complement. Yes? I am telling you that assume that the element X is in B complement. Okay, let me write in brackets. We show that. Can you complete this? This is the way that you need to think. We show that. Oh, come on, you are making me tired. Do you understand or not? This is simple. I want to show that B complement is a subset of A complement, yes? So I have to show whatever is inside B complement is also a member of A complement. Is this sentence understandable? Yes or no? Yes or no? Yes or no?
Yes.
Yes, okay. Now, I cannot, do I know anything about B? No. So I cannot say that, look, 1 is in B complement, 2 is B complement. I don't know what is inside B complement. So let me take a typical element. I will call it X. I tell you whatever you choose in B complement, let us call that chosen member to be X. We show that what? We show that. I will not actually budge if you don't. Yes?
That X belongs to A complement.
Yes. Why? Do you really know that or not? We want to show that B complement is a subset of A complement. So I have to choose an element from the B complement and try to convince myself this element is also in A complement. Yes? Yes or no? Okay, so we show that X belongs to A complement. You really don't need to write that, but I'm writing it because in the future, if you want to read it, you understand that. Even if you write it, that is not wrong. I can just write it immediately. So let me just move it away. So we don't need to write it, but even if you write it, that's not wrong. So this clarifies my strategy. I have chosen an element in the B complement. By reading this sentence, the audience will realize that what is the goal? What is coming next? I am using my energy, I am spending my energy to prove that this element is also in the A complement. Yes or no? Okay. Now, I start from here. We assumed that X is in the B complement. What is an immediate consequence of this? We just learned X does not belong to B. Yes or no? But can I conclude, this is my question for you, can I conclude that X does not belong to A? Yes or no? I have an assumption, you know, I haven't started with the empty hand. I have an assumption in my hand. My assumption is that A is a subset of B, and I am just trying to see. Can I now conclude that if X is not in the B, it's automatically not in the A? Is that understandable? Because of A is not a subset of B, yes? Because if something is not in the bigger set, how is it possible that that thing is in the smaller set? Do you understand what I mean? Because A is a subset of B. You tell me that X is not in B, so it is outside B. When X is outside B, it is automatically outside A. It cannot be in A. So the reason that this question mark is correct is because of my assumption A is a subset of B. Because of this assumption, this is a valid step. Yes? And now someone tells you that X is not in A. What can you conclude about X? If you want to, X belongs where? Definitely? A complement. What was my goal? We showed that X belongs to A complement and I achieved the goal. This is a very, very simple proof, but you need to understand it 100%. If you don't understand something in it, please let me know. We can discuss about that. Because this way of thinking is different from what you have used to so far. That's a pure logic, so I'm just playing with logic. Is that understandable? So it's very, very important. When you want to prove something in the set theory, ask yourself, if I want to show this, what I have to do to show this. If you want to show that a set is a subset of the other set, you need to pick any element. When I say that, so some question, I remember Dimitri asked, how do we know that X is in B complement? If that's also your question, let me answer it again. I don't know. I don't know what are the elements in B complement. I am telling you that there are some elements there, so let me pick X to be any element from those from the elements of the set. I call them X. You can start, let Y B belongs to B complement. We show that Y belongs to A complement. So do you understand the logic? It's important to understand the logic. So I can use Greek letters, I can use anything, yes? Any alphabet. Anyway, so this is a simple mathematical proof for 5. But remember that it's very important to remember those properties. Okay. Now I want to define the first operation between two sets, and that is analog to addition of numbers. In addition, we combine two numbers. If I have 2 and if I have 3, I add them, it becomes 5, which is greater than each one of those components. Yes? Somehow in the set theory, I want to have the same thing. I give you two sets. Somehow I want to be able to combine them. Yes? Open a new bag. Empty the content of each bag there. Okay? So that's the meaning of combining two sets. And there is a name for that, and that's called union. Okay? So let me just define for you the next operation. So definition. So let A and B be sets. Let me write it in this way. The union this is the word that I want to define. You cannot say addition or sub. That's the terminology. You need to respect. The union of sets A and B is denoted by of course, this is a little bit unfortunate. The symbol is very similar to the universal set, but in handwriting, whenever I mean universal set, I will put these small dashes to emphasize that is U. This is also somehow U coming from the union, but here I'm using it for the operation. The union of A and B is denoted by this, and it is defined as follows. Okay, can you yourself, you have some idea what I told you, yes? I open a new bag, empty the content of the first and the second into that. Okay, so how do you want to define the union of a set? So the union of A with B is equal to X in the set of course, the set of the universal set. That is not something restricting. All the elements should come from the universal set, but not all of them are acceptable. What are those elements that you might imagine that is acceptable for the union? You have an idea what is the union in your head. So can you define it for me? Of course, in principle, I should define it for you. Yes?
X belongs to A and X belongs to B.
No. It's very, very close, but this is, it has a flaw in it. Because when you say and, you need to be careful about that obligation. Yes? Do you want to complete it somehow?
No.
No? Anyone else, or even yourself? Yes? Or, not and. Yes. X belongs to A, or, I use this symbol for or, X belongs to B. So let me emphasize, this is a symbol for or, not and. Because I don't care if X belongs, because when you say X, when you say and, it means that you are forcing them simultaneously to be both in A and B. That is not my goal, yes? My goal is to care about elements that are either in A or in B, or of course both. And by the way, let me mention something. Whenever I use or in mathematics, it's a logical or. So logical or, this is the terminology, is not exclusive, it's inclusive. So usually, for example, you might say to your child that, okay, either I buy you an ice cream or a chips. Okay, so it means that probably if you want both of them, I will not buy it for you. Either. So this is not the case in mathematics, yes? So this or that I use in colloquial language is an exclusive or. Either this one and only this one, or this one and only this one. This is exclusive. But in mathematics, when we say or, and without explanation, without any explanation, it always means that it's inclusive. It means that either this one but not that one, or this one but not that one, or both. So or means this, okay? In everyday language. In mathematics always. Be careful about this. So let me draw a Venn diagram for you. So if I have this is the universal set. Assume that I have a set here, A, and I have another set. It has partial overlap with B. If I ask you, can you represent A union B for me? You would say, I am only interested in those elements that are either in A or in B, which automatically means that even if it is both in A, both in B, it's acceptable. So for example, this point is not acceptable because it is neither in A nor B, so ignore about that. Is this point acceptable? Yes, because it is only in A, it is not in B, but because I have or, so that is acceptable. Is this point acceptable? Yes. Is this point acceptable? Yes. So because this belongs to both of them. So it means that if I want to color that part, I need to consider all these parts. So this blue part that you see that I am making now is actually the union of these two sets. Yeah, let me be a little bit careful, don't give you the wrong impression. Yes? So this blue one is called A union P. Yes? For example, let us play around with this picture a little bit. For example, it might happen that I have this set. I do not have any overlaps at all. So where would be A union B in this case? Is this point acceptable? No. Is this point acceptable? Yes. So everything in A is acceptable. Is this point acceptable? Yes. Everything in B is acceptable. But is there any point that is simultaneously in both of them? No. But who cares? So if I ask you what is the union, color the union in this scenario, you need to color this and that separately. Yes? So this one is actually A union B. Okay, for example, what happens in this scenario? If one of them is in the other one. So can you tell me where is A union B? Where is A union B? Yes? Just tell it. The whole B itself, which also automatically includes... So I think this is something easy, you understand. So what's the meaning of the union? So here is A union B. Okay, so this is very important to understand the definition. But of course, let me ask you this question. Example. Okay, so for example, what is, if let me take set of numbers 1, 2, 5, 7, 10, and let me give you B to be 4 minus the square root of 2 and 10 and 11 over 2 and I don't know, 5. Yes? And I ask you to find, to determine the union A union B. How do you do that? What I do, I start writing the elements, all the elements of the first set. So what I do, it becomes 1, 2, 5, 7, and 10. And in principle, I have to add the elements of B to it. But we also have another rule. Do you remember? We do not have repetition in a set. So it means that if we have already mentioned an element from A, we don't have to repeat it. You shouldn't actually repeat it. This is a better example. So it means that I have to add 4, that's okay, because 4 is not already in my list. Minus the square root of 2, I added. Do I add 10? No, because 10 is already in my list, so I do not repeat it. But 11 over 2, I repeat it. And I will not repeat 5. So then I will stop. So that is the union of these two sets. Yes, is that clear? For example, of course, if I have this scenario, A is equal to A and B, and C and B is equal to C and D, and E, of course, in this case, A union B, I just write A, B, C, D, and E. It's automatic. But if there are some repetitions, be careful. You are not allowed to repeat. Yes? That's the only thing that you need to be careful about. Okay, any questions so far? So that's also a good question. So let me also write it here. So A is the empty set and the set of the empty set. And then, for example, you have B to be the empty set, and the empty set. So let me take this. So what is the union of A and B in this case? So again, what I do, I start writing all the elements. The cardinality of A is 2. It includes 2 sets. So I will repeat both of them here. And when I go here, I have to be careful. The first element is this guy, which is not already repeated. So I will write it down. But should I write the second element? No, because it's already in my list. So I will stop here. So that would be the union. So union of sets whose elements are also other sets can also be defined in a natural way. Okay, let me ask you some questions regarding the famous sets in mathematics, sets of numbers. I'm just trying to test how do you think about the problem. For example, what do you say if I union n with z? You see the set of natural numbers unioned with the set of integers. So what would be the answer, yes?
Sorry, the B, the set B. What was the cardinality of that one?
No, nothing. I'm just asking you that. So this is one element, this is second.
But you have a comma between.
Yes, that's a comma. Here?
No.
Here?
Yeah.
Yes, that should be a comma. So it means that the whole package is a set, including two elements, empty set and the set of the empty set.
Okay.
Yes, Dennis? This is what?
This is it.
This is z. Do you agree? If I union n with z, it becomes z itself. Is that right? Because z already includes whatever is inside n. So it becomes n. Okay, one more question. What happens if I have q complement union with the set of... Oh, sorry. So what happens there? Q is the set of rational numbers. Do you remember what I was? The set of irrational numbers. If I union them, what will happen then? Yes?
The universal set?
What is the universal in this case?
The set of real numbers?
Yes, you have to say the set of real numbers because universal set is a vague idea. It can be. So you have to write a set of real numbers. Yes? Why? Because any number that I pick is either a rational number or is an irrational number. Can it be both? No, in this case they don't see each other at all. Yes? Okay, so these kind of questions, I think they are easy so you understand them. But let us consider the properties of this. So let me write a remark first for you and I ask you to complete it for me. So if someone tells me that X belongs to the union of two sets, what is a logical consequence coming after the definition? What can I conclude? If someone tells me that, okay, I looked into the union, I saw an element X there, what can I conclude logically? Anyone else? Anyone else? Yes? Yes, it's X is in A, that's the definition. Or X is in B. I'm just repeating things because I want you to learn them. If someone tells me that X belongs to A or X belongs to B, can I still conclude that X belongs to the union? Do you think this implication is true or false? It is true by definition. If X is either in A or in B, can I conclude that X belongs to A union B? The answer is yes. Let me make it a little bit tricky. What about this thing? Do you think this is true or false? This is AND. True or false? Yes?
Is it true?
You are saying it's true. What about the other ideas? Is it true or false, this implication?
True.
True or false?
True.
True or false?
True.
Yeah, it's true. So even if it is and, it is still true. But be careful, from this direction it has to be or, not and. If someone tells me that X is in the union, there is no guarantee that that particular X that I'm talking about is both in A and B. But if I have, for being an element in A union, I only need that X belong to at least one of them. So I don't have any problem if that X wants to belong to both of them. Yes, so that's the logic, understand that. Okay. Okay, let me ask you one question. What is the consequence of this? I want to play around, because this is Math 5 actually. You need to improve the way that you think logically. So what happens if I tell you that X does not belong to the union? If you translate it, it means that you are a logical person, yes? So how do you translate that? What can I conclude here? Yes, Yovia?
So X is neither in
No. Think a little bit. May you say it again? Might be I.
I mean, okay, if we draw the Venn diagram.
No, just read it in English. X does not belong to the union of A and B. I can conclude that. Yeah, of course, yes. One possibility is, by the way, that's also good to know. If this does not belong to this, can I conclude this? Yeah, that is right, but that's not my intention here. Forget about using complements. That's a good thing to write. Yes?
X does not belong to A
And X does not belong to B. It's very important to understand. If you don't understand, let us discuss about that. Yes? If X does not belong to the union, it neither belongs to A nor B. Is that understandable? Because if X belongs to A, it has to be in the union. If X belongs to B, it has to be in the union. And now you are telling me that X is not in the union. So it means that neither this one is true nor that one is true, that X belongs to A or X belongs to B. Yes? So that is an immediate consequence. So it's very important to emphasize this is again and. It's really, really important to understand that is and. Is that clear? Okay. Now let us start some properties of actually a very important theorem, but a simple one. Okay, so let me write this theorem. This theorem is this is actually telling you what is the algebra of the unions of sets. So this is important. In the book, you don't see them under the title of the theorem. You see them spread around the exercises. But I want to collect them everywhere, all of them in one place. So if you want to study more advanced mathematics, this is one of those theorems that you can use without actually telling why this is true all the time. So, theorem. At least we want to understand it together. So let me give it a name. Properties of the union. Okay, so let us keep it like that. And I will say that let me write all of them together. A, B, and C be sets. And then, so number one, the first thing that I am sure that you can answer me immediately, what happens if I union a set with the empty set? It's very clear, yes?
It becomes A.
It becomes A, yes? So, it's like that this is acting like a zero and this is acting like addition. But of course, this is just an analogy. Don't push it so far. So this is the first property. Is that understandable? Yes. Now, number two. This is probably a little bit nicer. What happens if I union a set with the universal set? Yes? It becomes a universal set. So somehow I would say that if the sets are comparable, because you know that this is not the case that sets are always comparable, yes? The set A with this and the set this one, they are not comparable. This is not a subset of this is not a subset of this. But if two sets are comparable with the subset relation, then the union will be the bigger one. Is that understandable? Okay. Number three, let me make sure that I'm not, yes, that's correct. Okay, what do you think would be the difference between A union B and B union A at the end? Does it matter the order that I union the sets at the end? No, yes, because the order is not important when you look. So it means that this is commutative, yes? So this operation is commutativity. So this means the union of sets is a commutative relation. Sorry, an operation. Okay, so what do you think will happen if I have the union of three sets? Does it matter if I union these two first, and then union the answer with that, or if I do it the other way around, do you think the results would be different by the way that you have in your mind? Yes? Yes or no?
No.
So the answer is this. So this is associative. So it means that the addition, so the union operation is associative. I'm just giving you these names because might be you are interested in writing down, knowing about these, but you don't need to be worried about the names. So this, whenever I can interchange the roles of these components in an operation, it means that an operation is commutative. If it doesn't matter how I group them, if I have two of those operations, then it means that the operation is associative. Let me tell you something. Is addition with numbers that you learn in primary school, is it commutative? Yes, because it doesn't matter if I add 2 with 3 or 3 with 2. The answer would be 5. So addition is also a commutative. Is addition associative? Is addition associative? Yes, because if I give you this number to calculate, you will not complain. Because it doesn't matter if you add them first or if you add them first. The answer would be the same. This becomes 5 plus 4. The final answer is 9. Of course, this becomes 2 plus 7. But again, the final answer is 9. So addition is associative. Yes? Number 4. Sorry, this is number 4. I'm just probably a little bit crazy today. Number 5. So, let me see. Yes, more or less everything is finished except something that might be also interesting. What do you think will happen for this scenario for every set? I don't know what the set A is, but I want to union it with its own complement. Yes, Aman? It would be the universals. Yes? So that would be the universal set. Yes? Okay, let me add something to this. Let A be C and D be sets. Okay. I want to add something to it here before ending this. So if you tell me that A is a subset of B and C is a subset of D, it's very intuitively clear. So I have 4 sets. A is a subset of B, C is a subset of D. Now I union these two, A union B, and I union these two. Yes? So this is 6. You're laughing at this. Yes, I need to understand. Okay, C, U, D. Yes? Okay. So what can I, do you think it's comparable or not? If A is a subset of B, C is a subset of D, can I conclude something about A union B and C union D? If you just imagine the picture, that's very clear. I haven't written it in the full form. A union B, C union D. Are there any particular relations between these two? Using these assumptions? Yes?
Shouldn't A union B just be B? Because A is a subset of B.
Ah, very good. Yes. So might be I have it completely. Yes, you are right. Yes, you are right. And we can. So in this case, we cannot say anything because, by the way, that's also very important property. So he said that what is A union B here? B. Why? Because in these two sets are comparable and B is the bigger one. And then this would be D. Is there any particular relation between A, B, and D not mentioned? Yes? So if I write like that, there is no relation between these two. In general, might be there would be, but we don't know. But let me write it in this way. A union C, and then let me write it B union D. Is there any relation between them? What is the relation? Yes? Subset, yes. So can you just draw some analogy with numbers here for me? I'm not saying that it's a good idea to compare all these things with numbers, But in this case, I think you can mention something with numbers which works like that. What is an analog for this in numbers? Smaller than or equal. Yes? Okay, now what does it tell? In numbers, is it correct that if A is smaller than or equal to B and C is smaller than or equal to D, can I conclude that A plus C is smaller than or equal to B plus D? Is that correct? So this is comparable to this. I am telling you that understanding these analogies is good, but you need to understand the main differences between them. I am not saying that because this is true, that is also true. I'm just comparing them to remember, to be able to remember them more effectively. So if that's also the case, so I can union them side by side, the subset relation will remain valid. So I can say here, I can add them side by side, and this relation will remain valid. Yes? Is that understandable? Okay. So let me formalize this one as well here, because now you already know, but the tricky point is this. If I give you A is a subset of B, what can you conclude about A union B? You told me what's the answer. So if I tell you that A and B are comparable and B is the bigger one, then if I union them, what would be the answer? It would be B. But the nice thing is also, this also works in this direction, which is not that trivial. So this, I want to understand that this one, and then we are done. This is exactly the properties that I want you to understand. So every one of you actually could have understood what is going on in this direction, but might be the other direction is a little bit not clear. Yes? If I tell you that the union of two sets is one of them, it's very interesting. You can conclude that the other set is the subset of the answer. This part is not trivial, but that's also true. So I want to put this as an exercise, okay? It's not hard, but I want you to understand that because this direction is true, it's not necessarily the case that the reverse direction is also true. It might be true or might be false. Because, for example, in the numbers, if I tell you x is equal to 2, can you conclude that x squared is 4? The answer is yes. But if I reverse the order, can you conclude that necessarily x is equal to 2? No, because it might be minus 2. So some implications might be true, but the other way around it might not be true. But this is not one of them. This is one of those implications that in both directions it is true. Yes? This one you could imagine. I just want you to understand why this is correct in the reverse direction. That would be important. Some hard problems uses this direction to be solved. Okay? I will talk about that later. Okay?
But yes, that is only true when it's equal to B, because then you know which one is bigger.
Yes, yes. Even if it isn't, oh, yes, you are right. For example, if I have this, you can also say something. What can you say? B is a subset of A. But it is not that trivial. I want you to think about it. It's not hard, but not that trivial. So let us think about this, and I will talk about that later. So these are the properties of the unions of two sets. Okay, so let me give you some two examples, and then I will finalize. Okay, today's lesson. So this is the goal of these two examples is to try to use these facts, sending them to your memory, okay? Because these are important if you are interested. Okay, so I would write simplify. So let me give this example. Example, simplify. So you see, exactly like algebra. So I would say simplify. Of course, I am talking about sets, so whatever I am using is actually a set. So, for example, number 1, can you tell me what happens for this? If you tell me what A is, I don't have any answer for that. I just know A is a set. Yes, I know A is a set, but this is reserved for the universal set, and of course this is the union, and I union them, it becomes a set. I am talking about complement of the union. Yes, Carl?
Empty set.
No. Be careful. So what is the role of pair of brackets in mathematics always? So I have two kinds of operations. Union operation and complement operation. But which one is first according to the way that I have written them down?
The union.
The union, because it's in the pair of brackets. So first you have to union these two, find the answer, and then go for the next operation, which is the complement operation. So let me change my color to answer. So how should I, if I give you in the exam, how do you answer this? Anyone else? Yes, Jakub?
Okay. A union U is equal to U.
Is equal to U. Ah, Carl, sorry. I'm probably confused today. Thank you, you are right. So you, because you gave me the final answer, I was thinking that you want to do it step by step. Thank you. So you were right. Thank you. Sorry. So this becomes U. Exactly. Today, I'm actually confused. I don't know what I dreamed last night. So U complement. So this is U complement. This is not one of the properties listed here, but it was property listed before when I was teaching you the complement. What is the U complement? The empty set. So in the exam, if I ask you to do this, you really don't need to explain why and that. So if you write it exactly, but if you just give me the answer, it might be, I don't understand. Is it a random answer or is it a real understanding answer? So you need to write it like this and then this, that's okay. Is that understandable? Okay, let me do it once more. So, yes. Number 2, I will write this in black and the answer in blue. So I have written here B union, the empty set, and then complement union B. Okay, so from now on, if you want to answer it step by step. Not the final answer, because I don't know the final answer. Okay? Yes, so how can I simplify this? You see, do you understand? I am doing algebra. I don't know the set B. I am just simplifying using the rules. Okay, so what should I write here? So you see, I have 3 operations here. 2 of them are unions, and 1 of them is the complement. But of course, these pair of brackets play a role, yes? Which one has the priority here? Yes, this one. So what's the answer? I am unioning some set, I don't know what that is, but I am unioning it with the empty set. What would be the result? This would be B. Yes? And then I have a complement on top of that, and then I have to copy paste what is left. Is that understandable for everyone? But you shouldn't stop here because I can simplify more. What is the answer? Yes? What's your name? Nabila. So what's that? The universal set. So you need to write these 2 parts as the answer of this question. Yes? Yes?
Because you have said that the empty set is the subset of every set,
Yes?
so it feels weird to say that that's the first one. You know, that it's equal to the empty set because every empty set should be a subset of every set.
No, because so what I told you that B, so are you talking about this case?
Yeah, it doesn't matter.
So B union of this is equal to the empty set. You say this is weird? What do you say? Oh no, this is B. Are you saying that this is weird or what?
No, I'm just saying that because the empty set should be the subset of every single set, right?
Yes?
So it actually means that the empty set is already in B.
Not in B, it's a subset of B.
No, but isn't it the same?
Okay, so what's the question then?
Then the first one, the complement of U,
Yes?
shouldn't it just be, I don't know. It just feels that the answer is wrong.
No, if you feel the answer is wrong, probably you should have this feeling when I was teaching the complement. So we can go back here. We'll learn that the complement of the universal set is the empty set. Okay? Let me just try to convince you. I want to show that the complement of the universal set is the empty set. Yes? I want to show that these 2 things are equal. What should I do? I should show that this is a subset of that and this is a subset of this. Yes, if I want to show that two sets are equal, do you agree with me? One way to show that the sets are equal, to show that the left-hand side is a subset of the right-hand side and the other way around. So if I ask you what this is a set. What this is a set. I want to show that the sets are equal. So I need to check two things. I need to check the right-hand side is a subset of the right-hand side is a subset of the left-hand side and the other way around. Yes, if I can convince you of these two, then you have to admit that they have to be equal. But here I do not need to convince you because we have already talked about this, that the empty set is a subset of every set, including this you see here. So what I need to convince you of is just this one. Yes, I am trying to convince you that this is a subset of the empty set. Okay? So what can I do? I can take an element from here and show that this element is there, or the other way around. So that is exactly the proof by contradiction. I want to show that the universal complement set is a subset of the empty set. Assume that this is not the case, then what will happen? Okay, so how can I convince? Let me convince you in a different way. Instead of convincing you of that way, so are you having a problems with that one or not? Is that understandable for you? Is that understandable? By the way, if that's understandable, then that should also be understandable, because then what I do, I take complements from both sides.
Yes.
Yes, and the complement of the complement becomes the empty set. Yes? Yeah. But I understand, these extreme cases are a little bit non-trivial when you want to write them in words. Is that understandable now? Unless you say that I don't agree with this one. Yeah, this is simple. Yes, you can just do it. Okay. Let me write you one more here. Number 3. So I have written something like this: A union, A complement, union, the empty set. Am I right? Yes. And the whole package complement. So if you want to do this algebra, then what can I do? I hope that you agree with me. We have to start from here. Yes? So what does it mean? It means that I copy and paste this pair of brackets, I copy paste this operation here, I copy and paste these two parts, because I am focusing on answering this. But what is the answer to this part? A complement. If someone asks you why, you would say that the union of every set with the empty set is the set itself, so this is also true. But then, what has the priority here? This operation. Yes, so what's the answer to this? Yes, it is the universal set. Do I know something about the set A? No, and I don't need to in this combination. Because whatever A is, when I union it with the complement, it becomes the universal set. But I have a complement left on top. And then we know that U complement is the empty set. So you see, this is somehow like algebra. I am simplifying things without knowing exactly what are the elements inside my set. So what I'm saying is that these three equations that I got, these equalities, are always true regardless of the elements inside the set A and B. They are always true. Yes?
You said that the union had the priority in the second step.
Ah, but yes.
But
no, not the union. The complement.
Yeah, okay.
So that's also a good question. So here I have two operations, the union and the complement. But the complement has the priority because it's clear. For example, if I ask you add 2 plus 3 times 4, you can always do, of course here we also need a rule. Yes, you are right. But like that. So if I ask you to calculate this, which one do you think should have a priority?
The right one.
The right one, because you want to add two numbers. You can proceed with this if you know the numbers. You know 2 is 2, But you should know what is the right hand side. So it means that what is the right hand side? It is 9. So it means that you have to calculate this one first and that one. It's comparable here. If I want to union two sets, I need to know the elements somehow. So before knowing the elements, I cannot union them. So it means that the priority is with the complement. But that was a very good question. So I didn't mention might be I was automatically doing this. The priority is with complement and then the union. Is that right? Yes? Okay. So I think I can stop here. I don't know when the lesson is supposed to end.
15 minutes.
5 minutes?
15.
What?
15.
Ah, okay. So you have enough time to practice, yes? I don't know. First of all, make sure that everyone can see the home assignment, yes? Could you see it? Even the Google form, but please do not answer it because there is a question sheet and there is an answer sheet. So what you need to do, you need to open the PDF file. There are 5 questions, multiple choice questions. Solve them in a piece of paper, whatever, and then take notes from your final answers, and then open the Google form, and then put the answers there. And whenever you are sure, then push submit, because you can just submit it only once. And immediately you can see your score, which final answers are correct, which one are not. Okay, so this is the thing that and that's only for you, but I want you to do it regularly, because the grades that I receive from you, if they are really lower than 5, every question has 1 point. If it is, and 5 questions. If it is very lower than 5, it means that there is some misunderstanding somewhere, so I need to come back and adjust it. So that's more or less for my information. Yes? You are, of course, free to work together, but I really prefer to work alone, because I want you to have a feedback from what is going on, your understanding about the subject. Because Math 5 is a little bit different in nature, so I really don't know what's going on. Okay, so let me see. Yeah, you have. Yeah, I would say that in 10 minutes you might answer, I don't know, some of those questions. The first 2 or 3 are very, very simple. That's up to you, whatever you want to do in 15 minutes. And if you want to go from the class, leave the class, you can just do that, yes? And then let me see who is absent today. That's good. And by the way, there are a lot of exercises in the book. And I told you that, have you seen that timetable? I think 19 hours is dedicated to the set theory. 19 hours means that one session a little bit more than 6 weeks, yes? Because every week we have 3 hours together. So if I multiply it by 6.18. So, yeah. So you need to know that the exam will come a little bit later after the 6th week. Yes? So this you need to know. So please start doing the exercises. I don't know, if you want, we can end the lesson here. If you have any questions,